Hi, lovelies. In the spirit of zero illiteracy, we have limits here. So, celebrity mathematician. Now, what you have here, the first thing to do is to write solution. Now, we say limit as x tends to 2, 4 minus x squared, 3 minus root x squared plus 5. Now, this is what you have. The first thing to do is to substitute directly. And this will be what? 4 minus 2 squared over 3 minus root 2 squared plus 5, which is the same thing as what? 4 minus 4 over 3 minus root 9, because 2 squared is 4, 4 plus 5 is 9. So this will give me 0, right, over 3 minus 3, which is 0 over 0. And when we have this kind of a thing, we said it is indeterminate. If you press your calculator, this will show mass error. So if it is indeterminate, we'll apply a rule called L'Hopital's. Some students will tell you that take it to the hospital. So L'Hopital's is a rule we are going to apply in order for us to evaluate this beautiful young lady. Now, having seen it like this, we said this is what? Indeterminate. This is indeterminate. This is indeterminate. So if it's indeterminate, we apply what we call L'Hopital's. Apply L'Hopital's. L'Hopital's. So when you apply L'Hopital's, it simply means that we are going to take this limit in this way. That means the limit as s tends to 2, the function 4 minus s squared over 3 minus root x squared plus 5 will now be in this way. It will now be limit the function d, that is, we differentiate respect to this 4 minus x squared now be over, that is s tends to 2, now be over the same thing under 3 minus root s squared plus 5. So this is what you do when you talk of L'Hopital's, is for you to now differentiate the numerator and the denominator the same way before you can now substitute. In that case, we will find the solution. That's why some students call it hospital. That if it is indeterminate, you arrive at 0 over 0, it is mass error or indeterminate, take it to the mathematics hospital. And that is what L'Hopital's, by applying the L'Hopital's rule. Apply L'Hopital's what? Rule. Now, if we have it like this, we have to differentiate up and differentiate down. But in differentiation, this will be changed to this form. Look at it here. It will now be limit s tends to 2, the function d, the x is the numerator, 4 minus x squared, right? So this, for you to do this, you have to change this to a form that can be very simple. So it will now be 3 minus x squared plus 5 all raised to power of half. Now look at it here. Yes. So if you look at this thing very well, I have told us during the indices that when you have power 1 over 2 is square root. When you have power 1 over 3 is cube root. And when you have power 1 over 4 is fourth root. If you have power 1 over n is nth root. So this is 1 over 2. It covers this square root. Right? So if you have it in this way, then let's now differentiate. In differentiation, we say that if you have y equals x raised to power of n, in differentiation, our dy dx or y prime will be n x n minus 1. This is the formula for differentiation. So in this case, we are not going to do this. And if you differentiate a constant, is 0. Is that understood? So if that is understood, this one is a function of a function. Now let's just play with the denominator first. Let's look at what? Let's look at the denominator. I can do it straight, but I want us to understand what we are doing here. Right? I want us to understand what we are doing here. Now, if you are looking at the denominator, it simply means we are bringing this. Let's say that y is equals 3 minus x squared plus 5 raised to power of half. If you have it like this, we'll now say, okay, then let u equals x squared plus 5. Now, don't forget, our u is x squared plus 5. If our u is x squared plus 5, then y will now be what? 3 minus u raised to power of half. Now, this is a function of a function. We are just looking at the denominator. Now, I'll differentiate u with respect to s and differentiate y with respect to u. So, it simply means that the u, the x of this very function will now be 2x. Just the same way I told you, this one contains x, this one is constant. So 5 is 0. So you can say 2x plus 0, which is the same thing as 2x. The 0 here is the 5. If you differentiate 5, it will be 0. If you differentiate any constant, it will give you 0. And this x squared, the 2 will come down. I'll subtract 1 from the power 2. And x raised to the power of 1 is the same thing as x. That's why I did not indicate that one. So it will now be what? 2x. If you differentiate x squared plus 5, you have 2x. Now let us now differentiate the y, the u. So if we differentiate 3, it will be 0. And if we differentiate u, because we are differentiating with respect to u, if we take the u, it will now be minus what? Bring the half down. U, take the half, just as differentiation said, you subtract 1 from it. And if you subtract 1 from half, you have minus half. So this will now be equal to what? Minus 1 over 2 u raised to power of minus 1 over 2. That's what we have there. So now, but you remember that we need to get our dy dx. The one we form is a function of a function. So what we do, we'll answer, therefore, dy dx, let me do it here. I believe we're done with here. So this is our question. Now dy dx, dy dx is now equal to dy du, dy du multiplied by du dx. You can see that if we form this in this, we will still have dy dx. That is how function of a function is. So if we multiply it, that means dy du is minus 1 over 2 u raised to the power of minus 1 over 2. And now if we have it in this form, our u is what? s squared plus 5. So this is the same. This will now give us what? 2x. Right. Now, if we have it in this form, this simply means minus 1 over 2 dot 1 over u raised to the power of half, because since there's minus 1 over 2, if I bring it down, the minus will go away. So dot 2x. Are you seeing something here? Now, do you know that these two, this one is down, this one they are up. So this can go with this. Right. If that go with that, we'll now have minus 1 over u raised to the power of half dot x, which is the same thing as what? Equal to minus x over u raised to the power of 2. Now, we all know that our u is s squared plus 5. So I now have it to be what? That is the denominator, equal to minus x over x squared plus 5 all raised to the power of 2. All raised to the power of 1 over 2. Good. So this is what we have from here. But it's in the form of root before we change it so that we can differentiate. So this is our denominator. From here, if we differentiate this, you have this. So, and if we differentiate this, we have minus 2x. So we're now going to put them back. We have replaced our u, and since half is square root, it simply means minus x over the square root of x squared plus 5. That's what we have from there. Now let us now go straight, having known the value of denominator, that is minus x over the square root of x squared plus 5. So we'll now put it here, then differentiate the up. The up is 4 minus x squared, so it's very simple. So what we'll do is to come here, apply the L'Hopital's, so come here and go straight. So this will now be what? Now be equal to limit x tends to the x 4 minus x squared over the x 3 minus x squared plus 5 is the power of this. So this is what you have. Now, if we have known the denominator already, so it will now be equal to, if I differentiate minus x squared, I have minus 2x. So it will now be limit x tends to 2 minus 2x over this. We have known that is this. It will now be minus x over the square root of x squared plus 5. Good. So this is what you have. This is what you have. And in this case, you are not going straight because this is a division line. This line is for all of them. Some people are making this mistake. What you have here is this. Before you apply the limit, it will now be limit as s tends to 2. Now what you have here is, let's open the bracket to have minus 2x over 1, because this one is on its own. You now said divide by, this is a division line, minus x over the square root of x squared plus 5. Can you say this? Now, if you have this form, we know that we have to take the reciprocal of this. So it will now be what? Limit as s tends to 2. Look at it. Minus 2x over 1 multiplied by root x squared plus 5 over x. The minus is there. I know when you are doing minus times minus will take care of itself. So this will go with this, the 2 minus. So we now have what to have next. And this x also will take care of this x. So this x will go with this x. So what we now have is what? Limit as s tends to 2, the function 2 root x squared plus 5. Right? So, and x that is tends to 2, so we'll now say that is 2 the root of 2 squared plus 5. And 2 squared is 4. So this is the same thing as what? 2 the root of 9, because 4 plus 5 is 9. And square root of 9 is 3. So it will now be what? 2 times 3, which is equal to what? 6. And that is the answer.